Good evening, ladies and gentlemen. My name is Astrid Johansson. I am a Chief Marketing Officer at EDCORE. Today we will take a look at the essence of Industry 4.0 Smart Factory and give you a best practical practices of what to do in the future. We prepare this information not only for the large-scale device industry, but also for general manufacturing. We hope it will be helpful in many areas. OEE, overall equipment efficiency, is a hot topic in Industry 4.0. The goal of the OEE is to represent an ideal level based on theory. In terms of sales, it's an indicator that one should get 100% for all non-stop equipment, maximum production, and zero defect quality. While equipment has physical limitations, increasingly fierce competition in this area will require a different multidimensional strategy. The essence of Industry 4.0 is, to put it simply, to work effortlessly but dramatically increase the OEE. In general, manufacturing companies invest in equipment to gain competitiveness in the market to reduce the disinvestment period as much as possible. We have focused on improving productivity through intensive process innovation. The competitive manufacturing market ahead will eliminate the remaining losses, which can improve the overall equipment efficiency. When I saw the slogan in a factory, "An accident can occur with a moment of neglect, the employee responsible will be punished," I realized how inhumane management has become. In the meantime, systems in the information age are used to prevent loss in the field. People use statistical analysis to create a reference value and set the system accordingly. When a problem is detected, most of the time people find out root causes about it in real time. It's a human engineering first, post-system approach. In the system, you can't achieve OEE because it requires a lot of engineering effort, and there is a practical limit to modeling an accurate reference value. If this engineering effort and modeling is limited and insufficient, the detection sensitivity decreases, resulting in a loss. Quality innovation has evolved from job-specific activities and the mass production customer development process. In the 2000s, there was a cutthroat competition that expanded to Six Sigma quality management. However, even in the OEE era, will this mantra work? If it is based on human effort, it would require 24-hour real-time engineering, which is beyond human limits and most enterprise resources. Management systems adopted this approach, from which we have modeled a number of baseline values. To improve the OEE, a new method of quality innovation is needed that focuses on people and enables 24 hours real-time engineering. The following illustration depicts the innovation in traditional manufacturing. Whether it's a device industry or small and medium-sized manufacturing, common equipment production and process technology are critical. Because of the goal of manufacturing is to keep the equipment stationary, maximize production, and avoid defects, the engineer is responsible for monitoring, evaluation, root cause analysis, planning, and taking action. To continue to innovate this part, we've simplified and standardized this process. ERP, MPR, barcode, etc. Level 1 are computerized. However, in the case of process device industry, such as semiconductors and displays, requiring large equipment investments, which have faced extreme cost wars in the marketplace, enterprises went beyond computerization to level 2 automation. At this time, the philosophy of Industry 3.0 information age was early sensing and speedy response. The goal was to detect real-time loss at the site and take action quickly. The automation of this era was through statistical analysis to determine values of control criteria. It required finding production optimization rules, developing various models, and applying them to the system. In other words, to revolutionize equipment production and process engineering with computerized and automation. There still remain losses because there's a lot of human efforts required. In Industry 4.0, this is the essence of the competition. Let's take a look at how we can overcome it with level 3. In Industry 4.0, the artificial intelligence is critical. The key technology that enables 24 hours real-time engineering is Software 2.0. In this information age, Traditional systems such as ERP, SCM, MES, etc. have a framework, but the content is made up of specific people's requirements. Engineering activities must be carried out in advance, setting and updating logic and reference values for operation. It means that there are many things that people have to do before running the system. To elevate this effort, Software 2.0 has infused intelligence into the software. This intelligent software creates AI models with big data and enables application to take advantage of events in real new environment to evolve autonomously. We should transform these traditional software to be Software 2.0 for Industry 4.0. Let's look at the methodology of building Software 2.0. Industry 4.0 system is not separate from the existing information age system. It is similar to the process of human statistical analysis and big data engineering of the past. The difference is doing unlimited iterations and working on endless data science activities until an optimized answer is reached. Artificial intelligence will find out root cause and the relationship between the cause and effect to predict the future. This is what it looks like running based on event mesh, constantly searching for answers through mutual event exchanges. In other words, artificial intelligence continues to do engineering instead of people. At this time, what the engineers need to do is continuously discover data and try to improve data quality. We'll cover that later. As a practical example, using a solution called Snotra, we will explain the vision of the Industry 4.0 Smart Factory. Snotra developed for OEEs an intelligent process control ecosystem. Several artificial intelligences developed as a real-time machine learning platform tightly connected by event mesh based on virtual manufacturing, cyber-physical system. Following services are implemented with this philosophy. FDC without specification setting, SPC without prior statistical analysis, APC without DOE, and virtual measurements, etc. In a manufacturing environment changes without human intervention, process engineering is performed in real time 24 hours a day. Let's investigate a few key functions. First, in artificial intelligence, there is a ridiculously difficult situation, that is, manufacturing environment changes forced to retrain model continuously. Therefore, advanced self-learning techniques are needed. This self-learning is not only reinforcement learning, but also the domain knowledge based on systemization. Second, in the manufacturing environment, the key causes must be extracted as quickly as possible and modeled accurately. Realistically, however, it is difficult to improve data science capabilities in a short period of time. For small and medium-sized manufacturers, hiring data scientists is very difficult. That's why easy, fast, and accurate machine learning solutions are indispensable for smart factories, smart farms, smart distribution, etc. In every field of artificial intelligence application, this concern is a general issue. Snotra's robotic process automation provides real-time collaboration between humans and artificial intelligence. Artificial intelligence does predictive tasks and resolves systematic problems. The domain expert innovates environments for resolving the random problems in the field. We need to create a new digital process culture that works together organically. In Industry 4.0, for achieving highest productivity, artificial intelligence becomes a close human companion. Human beings make the most artificial intelligence to create synergy is the key to success. Next, there is a real-time virtual manufacturing of CPS. In general, productivity and quality are always conflicting trade-off relationships, but we have to do our best to improve the OEE. Snotra VMs based on artificial intelligence, the CPS solution that describes manufacturing situations and trends by various predictions. To improve productivity, it is possible to do the sampling measurements without worrying about quality. Most importantly, you can achieve the parametric measurement effect even though sampling measurements would be done. Intelligently guided smart sampling provided by CPS is a valuable feature. In addition, CPS provides current and future process performance trends throughout the plants based on event mesh CPS context. It prevents quality problems caused by existing process control malfunctions and dramatically improves root cause in chronic FTC problems. The CPS based on event mesh Snotra VM is key to enabling AI-based smart factories. The most important part of manufacturing is the sensor. It is difficult to set up accurate specs for many sensors, even if they've done numerous times modeling. In the case of semiconductors, display manufacturing, fine-tuning the parameters of equipment has a significant impact on quality. Also, we need these interlocking mechanisms for control. Most of the sites have difficulty setting up specs for sensor. If the environment changes, setting has to be repeated. To make matters worse, there may be other problems. Frequently, there's time series data and non-parametric data, and an additional remodeling is required for practical reasons. If spec can be set up with meaningless wide range spec or other values just from human experience, this causes a number of caustic genetic errors, and eventually investigation efforts will cause inefficiencies. Once we connect sensors, spec is generated automatically without modeling efforts. Snotra RMA and artificial intelligence with real-time mathematical insight engine resolves this problem. Snotra RMA FDC runs as soon as sensor is connected. This makes Industry 4.0 possible. Finally, the task of analyzing the process and creating a control model is now possible with artificial intelligence. Process control system refers to a control device that automatically adjusts the input conditions of the process to accurately achieve the quality goal. In the case of discrete factories such as semiconductors and displays, it's called R2R. As with these chemicals, the R2R control systems must experiment with dough for many processes to create a control model and update the model frequently as the environment changes. Traditional R2R control systems are struggling with these engineering challenges, and there's a huge cost of development operation. In addition, process control errors caused by inaccurate dough are directly linked to large quality problems, so only passive control is required to avoid them. Artificial intelligence Snotra APC is executed by simply doing system identification for the process. The rest is left to the artificial intelligence because AI does the real-time engineering for you. We support CISO, MISO, and MIMO control models without DOE and SI. Most notably, artificial intelligence automatically controls by self-learning on CPS context, providing safety and accuracy that are far better than those in the past. In the third wave, Dr. Alvin Toffler wrote, "Human beings are anxious about the new environment and try to return to what they're used to, and at some point he finds himself adapted to a new environment. Human beings cannot stop future progress and change. We have to be ready right now, as Industry 4.0 manufacturing is expected to compete fiercely to maximize OEE with the help of artificial intelligence." In the fourth waves, even meshes that connect everything to IoT and artificial intelligence handled by cloud technology is crucial. Before the tsunami comes, I would like to pinpoint a few things that we need to prepare for. Above all, successful application of artificial intelligence depends on the quality of the data. This is not the data quality mentioned in systems such as EDW and BI in the past information age. The existing information delivery infrastructure and information architectures are for management purposes. This is not criticism of the infrastructure, but emphasis of the differing requirements of Industry 4.0 artificial intelligence in order to enable a combination of mathematical insights. This will overcome several blind silos that existed in the previous age, such as but not possible loss during planned maintenance, and improve performance and stability of high-capacity information delivery systems. The most important thing to refer to is that you have not deployed artificial intelligence if you don't have autonomous architecture, a high-performance event platform, and an application ecosystem. Artificial intelligence increases accuracy through learning. The first stage is using data, and the second is real-time relearning. Real-time relearning uses data, but after execution, real-time events are reflected, which requires multiple event exchanges. The event platform is built on high capacity, high quality, and high connectivity, high maintainability. Snotra leverages Solid's technology and event platform that is dramatically increased maintainability with simpler structure and very powerful in performance and reliability. This is because these technologies need to be leveraged to handle Industry 4.0's 0.01 second or less sampling data and events. The most important re-engineering topic is MES, the backbone of the production system. The information age system is the Industry 4.0 system and needs to be changed. In the past, for semiconductor manufacturing, during the change from 200 millimeter wafer production to 300 millimeter wafer production, there were a lot of problems that cropped up that had not been anticipated before. They were solved and the transition was completed. Industry 4.0 MES requires artificial intelligence, which needs to be able to handle unexpected issues of high capacity, high density data, and more considerations will be needed with respect to data quality. Features and data that were not required by the existing CIM will be added. For artificial intelligence, measures of quality data from equipment, processes, and infrastructures will likely be required in all areas. In conclusion, MES needs to transform itself into an artificial intelligence capability with new architectural technologies based on ecosystem and event mesh. Lastly, to become a smart AI, you need a big data that can learn from many perspectives. The data of the existing information age system may be less than 1/100th of data that we will be able to benefit from for the next generation, which means that continuous data discovery efforts are needed. In addition, data discovery efforts make data connectivity important. One example is sensor data and data transportation capability. We don't know where the sensor is going to be. We can't necessarily put in a cable, and there's a lot of radio interference in the field. Snotra solutions are wireless and use mesh network technology. I've explained the Industry 4.0 to my factory so far. Artificial intelligence and people need to work together to improve OEE. To work with artificial intelligence, we need to quantum jump from the existing systems and infrastructures. If you aim for OEE without doing re-engineering, you cannot do anything, fail, and lose. In order not to be swept away by the tsunami, innovation is needed right now. In this era of Industry 4.0 manufacturing competition and the digital process war by people and artificial intelligence collaborations, the first step is to distinguish between what people should do and what artificial intelligence should do. If you have any questions, please send us an email at desu@edcore.co.kr and we'll be having an answer sessions. Thank you for listening.